This one is 3.23 part G. Here we have a simply support beam with uniformly distributed load, and we have to draw the shear force and bending moment diagram using singularity functions. In terms of support, we'll have R1 support here, R2 support here. This UDL that is given can be replaced by a simple point load right at the center, because it is applied on a distance of L plus A. This force is going to be W naught L plus A, and the distance is going to be same from both sides. So this is L plus A divided by 2. We can write down the force and moment balance. So R1 plus R2 is going to be W naught L plus A. Similarly, if I take moment about this point, we will have R2 times L, which is counterclockwise moment, equals to W naught L plus A whole square divided by 2, because of this force here which is sitting at this distance. So using these two, I can solve for R1 and R2. The value of R1 we get is W naught divided by 2L, L square minus A square, and the R2 value we get is W naught divided by 2L, L plus A whole square. So these are the two reaction forces. Now looking at this beam, we have point load and then we have UDL. So for point load we are going to use x minus A minus 1, and for UDL x minus A 0. In terms of integration, this will become power 0 after one integration and power 1 after second integration, and this right here will become power 1 after one integration and power 2 divided by 2 after second integration. So now we can write down the intensity function. So we start from the left hand side. So we have R1 here. So R1, this is at point x equals to 0, so x minus 0 minus 1 because of point force, and then we have the UDL, which is minus W naught, again starting at 0, and because of UDL power is going to be 0. Third one is your R2 reaction here. This one is at L, so x minus L, and power is going to be minus 1. Now to get your shear force, we can integrate this one time, and similarly one more time integration will give us your bending moment. So if you look at your shear force, this is going to become minus R1 x minus 0 0 because of integration, plus W naught x minus 0 to the power 1 minus R2 x minus L to the power 0. For the bending moment, if you continue this integration with a negative sign, this becomes R1 x minus 0 to the power 1 minus W naught x minus 0 to the power 2 divided by 2 plus R2 x minus L to the power 1. Now in this beam, there will be two sections that we need to check. One is your x less than equals to L, and this one is x greater than L. So we can have two segments. So first one is segment number 1, which is x less than equals to L, and then we have segment number 2, which is x greater than equals to L. In segment number 1, only these functions will play a role, and in segment number 2, all three functions are going to play a role there. So if you evaluate your V1, looking at this first one here, is going to give you minus R1, x minus 0 to the power 0 will give you 1, plus W naught x coming from this second function. Similarly, your MB1x, from here we are going to get R1 times x, and this term right here will give you W naught x square divided by 2. Now when we come to segment 2, segment 2 is going to be all three functions, but first two we have already calculated in V1, so we can write that down, minus R1 plus W naught x, that's coming from V1, and this last function right here, this is going to be minus R2. Similarly for MB2x, we'll write down the MB1 value, which is R1x minus W naught x square divided by 2, and the last term here, which is going to give you plus R2 x minus L. On these expressions, we already know the value of R1 which is equals to W naught divided by 2L L square minus A square, and your R2 W naught divided by 2L L plus A whole square. So I'm leaving the algebra part for you to sort of simplify these values. I'm going to just give you the plot. So let me draw one axis for this. Now here I have an axis system with the convention that we are following, and if I have to plot this V1 in segment 1, which is x less than equals to L, we can evaluate this at 2 points, x equals to 0 and x equals to L. At 0 the value for this is going to be minus R1, so this is minus R1. At x equals to L, this value is going to be minus R1 plus W naught L. So I can connect both of these points using a straight line. Now this point right here, which is where the shear force is going to be 0, this is equals to R1 divided by W naught. So this is how your shear force is in the first segment. Now in the second segment we have this function which we need to plot. Now this we can evaluate at 2 points. One is at x equals to L and x equals to L plus A. Now the value of this function at x equals to L plus A is going to come out as 0, and at this point here the value is going to be with the difference of R2 that we have. Okay, so the value right here is going to be something different. So if I look at the value right here, this is minus R1 minus R2 plus W naught L. So if you notice, the difference between this value and this value is exactly equals to the reaction force that we have. So this is how your shear force diagram is going to look. Now this point is important because this is where your shear force is 0. So your bending moment is going to get a peak there. And looking at the bending moment, we have to plot this function. This is a parabola opening downwards, and from this figure we can see that the peak is going to be somewhere here. In terms of values, we can again evaluate this at these 2 points. So here it's going to be 0. At x equals to L, the value that we get is minus W naught A square divided by 2. So now we can connect these 3 points. So your parabola picks up in this manner and then it drops down on the other side. So we get a curve like this. And for your MB2, if you simplify this, you're going to get that this is also a parabola opening downwards, and the shape of this parabola is such that the peak is going to come at x equals to L plus A. So this is how your bending moment diagram is. On the negative side, we are getting this value here, and this peak right here is W naught divided by 2 L square minus A square. So that's how the shear force and bending moment diagram is for this given beam.